Mr. Bob Ripka.
Good day, everyone. Today's topic, steam valve sizing and selection, where we're going to go over steam systems to see where we use our steam valves. Applications in coils and heat exchangers, that's generally where you'll find us, and some other applications we'll look at real quick, but for the most part, in our HVAC world, that's where we live. The required information to size a steam valve. Steam valve sizing, how we do it, steam temperature control valves, what is available and where to use what, and selecting the correct control valve. Then I'm going to show you our SelectPro system, how easy we've made it to do this. Please keep in mind the steam valve sizing formulas and whatnot are industry standard. It's not something that Belimo came up with or not something that I came up with. It's what's been used throughout the industry for as long as I can remember. And some people have different ideas about it, which is fine, but the system that has been used from us and the other major manufacturers seems to work really well. So steam system, there is a steam system. We have our boiler or teapot on the left of the screen, and it's making 100 psi steam. It's boiling water and making steam under pressure, right? You need to get the temperature and the pressure. You have to pressurize the system. And as we go down, we see a PRV, a pressure reducing valve. That's not Belimo product, that's other manufacturers. And that reduces the pressure, in this case, from 100 psi to 7 psi, where we go out into our typical HVAC system. The HVAC system, here we have a little unit heater, and you can see steam piping has to be very specific. It has to drain continuously. We take the steam off the top of the header, and the steam goes into that coil as a gas. And then there's the gas, the steam in the red. Then it's going to turn into a vapor and then condensate. So we're going from a gas to a vapor to water. And that makes it part of the challenge to deal with steam and to regulate the flow of steam. Our control valves are for controlling flow, not for controlling pressure. So through the coil, where we take the temperature drop, we transfer the energy of the air from cold to hot. The trap holds back the steam until the steam turns into water, until it turns into condensate. Then it fires it back and goes to a receiving tank where it mixes with make up water and then back to the boiler to make more steam. I just like this statement because for years people have been saying that steam will go away, and it's still one of the best agents known to take heat from a source in one location to form a service in another location. No distribution pumping is required. It will travel a long distance. It's very hot, and it will go. It'll travel a long distance without being pumped and maintain temperature. Typical application here is a heat exchanger, a steam to water heat exchanger where we might be making hot water to heat a building. Steam in through the coils of the exchanger, down out through the steam trap. Water in, out through the pumping system, through a load, which would be an air handler unit, whatever. Transfer of energy, and back to the heat exchanger. See, typical, I just painted in that Belimo valve there. On heat exchangers like this, you'll commonly see 1/3, 2/3 to get better control. You get better control at different load demands, because the load demand on that heat exchanger, let's say it's a hotel, in that early morning hours when everybody's showering, is dramatically different than the afternoon or the downtime. So applications, where do we use steam coils? Preheat and reheat coils in our air handler units, radiator fin tube in of the Northeast, I still have a lot of radiator fin tube that is steam driven. Steam fan coil units, unit ventilators, very common in schools that they still use low pressure steam. Unit heaters, of course. Sterilization, not too much in our industry, but we do see quite a bit of it. Hot water storage. Humidification, I do see quite a bit. Spargers, these steam spargers that inject humidity into the airflow. Very specific valves used on that, generally wear the isolation valve on those sparger systems, and other manufacturers make the whole package. Sizing steam valves, pressure and pressure drop, industry standards. I can't say that enough. The critical pressure drop is the point at which any further pressure drop will result in increasing the steam velocity. In other words, you increase that pressure drop, you're getting no extra steam. The approximate value of which the critical velocity occurs is 45% of absolute inlet pressure. So gauge plus 14.7. Now 45, some people are saying, oh no, it's 42. They're right. And you'll see I use these different numbers. Through the industry, I've seen 42, 43, and 45. It's not really going to change anything. So in this example, I just used 45%. The definition of low pressure steam is below 15 psi. Low pressure steam is pressure psi G, below 15 psi. And it's always good, handy to remember, steam pressure is totally related to steam temperature, saturated steam. 15 psi, 250 degrees. Very easy to remember. So you collect, what they tell us when we're sizing low pressure steam is to select a pressure drop up to the inlet pressure, which confuses people. But this is not water sizing. This is not Bernoulli's formula. What the industry has standardized in is take an 80% drop. That is is recommended by our sizing tools and by any manufacturer I have ever used, or any calculator or formulas I could find. For high pressure steam, on the other hand, you take 45% of absolute pressure. And I'll show you how easy this has become over the years because of these new tools, Excel, and other tools that we have. But it's important, increasing the pressure drop beyond critical does not result in any more steam flow. But one of the biggest requests that I'll get is that, oh no, I'm not taking 80% drop, I only want to take 50% drop. You can make the valve bigger. And making the valve larger is one of the biggest, oversized steam valves is one of the biggest issues that we run into in the industry. You know, basically we have to keep in mind most equipment is oversized to begin with. And the 80% rule has worked very good. And I'm talking more about the 80% rule because in our HVAC industry, we generally live below 15 psi. So required information to size a low pressure steam valve, 15% psi or less, is very minimal. The steam pound per hour, of course, that could be an MBH and you can convert it, and the steam inlet pressure. The steam inlet pressure being the inlet pressure that the coil, the heat exchanger, was designed for, which will be on the specification. So it might just say it's 2,000 pounds per hour steam load, or that would be somewhere around 1970 MBH, and the inlet pressure designed at 7 psi. So that's what we use. We use that 7 psi. So when we're sizing new systems, we take this off of the equipment schedule. And the other thing I like to point out is that I say in this note here on the bottom, most calculators, I've never seen a calculator that didn't take 80% of the drop. So then we have to know, what do we want our valve to do? We have to know the voltage, because we're talking control valves. Is it modulating, proportional, or is it on off? the normal position, if the valve loses the control signal, do we want it to open or close? The fail position is if we lose the power, do we want the valve to open or close? And very important, this is rule of thumb, we've always said heating open, chilled water closed. That's not, that's not cut in stone anyplace. That again is just a rule of thumb. Heat exchangers, steam to hot water heat exchangers, generally always fail closed because you don't want stagnant water and let the steam valve run and cook out the heat exchanger. So that's, again, these are just rules of thumb, but they're good. They're good rules of thumb that the industry generally follows. Two-position valves. Now, a two-position valve is just for isolation. It's just on-off. So generally, people will just use line size. Back in the day, quite a while ago, a lot of people would just go down one pipe size, which I have to believe 97% of the times is going to be fine. But if you did want to size it, just to make sure the CV of the valve, the coefficient of the valve is large enough, on or off, you take a 10% pressure drop. A system pressure of 10 would take a 1 pound drop. It's as simple as that. And again, there's formulas that you can go through the exercise if you would like, but there's calculators that will do on, off, or modulating. So here's the example. Here's the math for a on-off system taking the 1 pound drop, with the inlet at 15 at 200 pounds per hour. And down here we have first the identification, CV, the valve coefficient of flow. The CV is the true size of the valve, the true cross-sectional area of orifice of the valve. Pounds per hour of steam, pressure drop across the valve is a constant, and then you calculate outlet pressure and absolute. And so with this calculation, we came up with a 10.25 CV, where we would go into a book and find the closest valve up. That's what ASHRAE says. Choose the closest valve up. So again, we're oversizing. And we would design for that real cold day. You know, it's a tricky thing. That's why it's so important to follow good standard guidelines. Proportional control of steam. Now this is what we do. This is, when we do valve schedules, this is the vast majority of what we do. And again, the formula will ask for an 80% pressure drop. This is for calculation. The actual functionality, I don't really know, but this is for calculation. So for low pressure steam, when you're using a calculator, it'll take 0.8. For high pressure steam, I see I changed it to 42% here. Again, it's not going to change anything. And there's your proportional formula. And this time it's 100 pounds per hour at 15 PSI, and I have a CV much smaller of 2.29. So there's the math. And again, if anybody wants to go through this math, this presentation will be available to you. This is the way to do it. This is a calculator. Now, this is a calculator we used to use, and this will calculate CV for you. There's an example in here. This isn't live, so I can just show you the example in here of 66,000 pounds per hour with a 10 PSI inlet, and it's telling us that we need a CV of 190. So we need a 4-inch valve. And it shows you your math. And if it was high pressure, your answer would be down here. This is a nice calculator. If you're interested in getting one of these, if you contact your Belimo sales rep, they should be able to get this to you. We don't use it anymore because we have a much better system now. We have a system, and I believe it's the only one available, that actually selects the entire valve for you. What I always liked about this, it had this little BTU calculator over here. It does corrected CV It does the pipe factors. If you're coming down more than 2 pipe size, it's recommended to calculate a calculated CV because it's going to reduce. At a specific pressure drop, which you want to maintain through an orifice, you can only get so much steam. So that's why this is important, that after you did your sizing and you're going from, say, 6-inch pipe to 4-inch, you might just want to check. Because here, valve size 4-inch, pipe size 6, actual CV is 360. We knocked it down to 320. You want to make sure that you're in the range where you have to be when you calculated your CV over here. If it's in MBH, just calculate it here, just adjust the math for you. That's all that does there. And I have much different numbers here with a real small 3.78. I got 66 MBH and a 3-pound inlet. That again is all off the specs of the coil that I'm controlling. So this is a nice tool. Steam temperature control valves. What do we have for different applications? Now, you know, it's per or pursuant to what the engineer spec'd, or you talk to your customer, you talk to your end user, and they said, I have low pressure steam, fan coil units, and I need control valves. Well, for low pressure, 0 to 15 PSI, why I put 249 here, it's generally 250, I don't know, but again, that rule of thumb, 250, we have this HTCCV, high temperature characterized control valve. The wonderful thing about this is how small it is. It's a very compact valve. It will fit in terminal units. It's very easy to use, and it's great performance. Fail-safe, non-fail-safe, all the functionalities, all the great Belimo functionalities. Then we have globe valves, 1/2 inch through 6 inch. This valve is only 1/2 inch through 1 inch. A little higher on the CVs, which is nice. But the globe valves go from very small, 0.4 something, up to 370 CV. And they'll do low pressure or high pressure, which I'll show you. For medium pressure, we have globes with bronze trim. Globes with bronze trim. Medium pressure, we're defining here as 35 PSI. That's Belimo standard. Some people say 50, some say 35. For medium pressure up to 35, bronze trim globe valves. This is a tricky one here. Butterfly valves on steam, not very common. There are special process valves for steam control. The only place we would use butterfly valves for steam would be isolation up to 50 PSI. That's it, and they have to be high performance valves. Not our standard product, they have to be what we call our ANSI 150s or ANSI 250 valves. For high pressure up to 100 PSI, we have our V-ball, a very high performance valve, and our stainless steel globes, 1/2 inch through 6 inch. So in other words, we got it covered. Any application in the HVAC world, we can cover. The G26C compensated, that means 2.5 through 6. Very, very high close-offs on that line. The CS is the same valve with stainless steel trim, again above 15 PSI, but a lot of engineers will spec stainless steel trim for any steam application. We have linear or equal percent. Linear or equal percent. Some things you read might tell you that linear for steam control, but on low pressure steam, a lot of people, including me, like equal percent because our loads vary so much with low pressure that equal percent will give us better control at the low end. So we've had great success over the years using equal percent valves for low pressure and below 15. High pressure steam, much better to select the, no, high pressure steam, absolutely linear, absolutely stainless steel. So these valves are available in bronze or stainless steel trim, ANSI 125 or ANSI 250. Again, we can meet the spec. This is a typical submittal, and I just put the arrows in here. We're looking at steam. And on the top here, I have the G6C, that's the bronze trim, then the G6CS, the stainless, and the stainless linear. See, the linear only comes with stainless steel trim because it would be a high pressure application. And we looked and we saw that our system was 30 PSI, so okay, I can use the C, or I can use any of these valves. I looked and my system was 70 PSI, I can only take the CS or the LCS. And then it shows you steam temperature rating. And of course, steam temperature is totally relative to steam pressure, so it's 280 degrees. And these are 338, which is 100 PSI. And then it shows max differential. And again, on max differential, well, on the C valve, it's as high as the inlet pressure, so you can just not worry about that at all. And on the other two, it's 50%. So again, you're very safe with max differential. They spec out very strong here. And you can see modified equal percent. Again, for low pressure steam, that's a great selection. This is the threaded product, 1/2 inch through 2 inch, threaded NPT, steam, or stainless steel or bronze. And there's the difference. The seats, the plug, maximum inlet from 35 on all the bronze globes up to 2 inch to 100 on the stainless steel product. Media temperature range, well, 280 and then 338. The differential is higher on the stainless, 50 PSI of maximum differential compared to 20. And a great thing is the leakage. Class 6 leakage. That is a superior class leakage. That valve's going to hold, when it's turned off, it's going to hold very, very tight. So the HTCCV I talked about a little bit. This is up to 15 PSI. Great for small air handler units, fan coil units, terminal units, any small terminal unit. It is really a compact solution compared to a globe valve. The specific picture I have there is a fail-safe. That's a spring fail-safe system. 1/2 inch through 1 inch NPT. 0.29, so we have very low CVs on this, up to 28 CV. Great range of CV selection, so you can get that valve closest to what size you actually calculated at. And again, like I said, it's small. HTC CV, not much to show you here, 15 pounds inlet, 250 degrees. And maximum differential is as high as the inlet pressure. And this is also bubble tight service at 0% leakage. So again, it turns off, you don't have an issue. There it is. Should have put an arrow there, I guess. Leakage 0%, what we used to call bubble tight. Again, this one you got to be careful with. This is a high performance valve. If you needed a steam isolation valve to do a changeover system, this is a great selection because it's bubble tight. It closes off very tight. It's all Teflon trim, Teflon seats with stainless steel trim. So it's a good selection, but only for isolation. The F6 series, and again, not too much here, but you can see it's stainless steel trims, Teflon, up to 50 PSI. So selecting the correct steam valve, whether we're working with the customer direct or if we're working off equipment schedules to determine what size valves we need to know the steam flow. What is it in pounds per hour? If they're giving it to you in different forms, if they're giving you BTU, if they're giving you MBH, you have to calculate it into pounds per hour. steam inlet pressure. And the steam inlet pressure will also determine the trim, as we discussed. Then as far as the actuation side, we need to know the voltage, the control signal, is it modulating or is it on off, or any type of signal. Belimo MFT technology is all we use. That's multi-function technology, and you'll see that in a moment. So you have all kinds of selections if you wanted not to go 2 to 10, if you wanted to go 2 to 6, 3 to 5, whatever, you can do this with our technology. Again, is it normally closed? Is it fail closed? You have to know that. And you have to make sure that you have enough close-off pressure. Without systems, that's usually not going to be a problem, but it's something you have to know. So, if you go on belimo.com and go to Solutions, Resources, Tools, then download SelectPro. SelectPro is the tool we use for sizing. And I'm going to show you, we're going to do a selection right now, and I'll show you how easy that is. I have SelectPro open. When you open SelectPro, there's a lot of tools in it. There's a tool to do pipe packages, actuated damper sizing. You can select the proper actuator. Retrofits, if you have old other manufacturers, and if you know the part number, there's universal kits. This will select the proper actuator and linkage for you for either damper side or for valve side. Our complete sensor line is in there, so you can select the sensor from here. Quick quote if you know what you're looking for. So today, of course, we're going to look at valves, and we're going to look at steam valves. But up here, it shows you our energy valve, our electronic pressure independent, 6-way valves, our very wonderful zone valve, bubble tight close off, the PIQCV. But let's say this engineer specified terminal units and he wants to use the HTCCV for steam. It's a low pressure system. So I selected that. Otherwise, I would get all my steam valves. But we know what we're looking for. So we go here and we have to change water to steam. And we get a disclaimer right off the bat. The next thing you have to choose, but you have to sort of remember this, is that you want to, with the proportional, so you want an MFT configurable. And now it will allow you to put in the pounds per hour and the inlet pressure. So I'm going to use 200 pounds per hour with an inlet pressure of 5, and I get my CV calculated. You know what, let me use an inlet pressure at 10. I kept doing this different ways. And I get a calculated CV of 5.77. Now, because it knew it's HTCCV, it put in the valve parameters for me. It's a 2-way, it's stainless steel trim, it's a non-ANSI, it's a WRG valve. Pipe size you can put in here, and I'll show you why. If it's 3/4, it's fine. If we put in 1 inch, if we put in 2 inch, it's going to stop you and say, why are you putting such a small 3/4 inch valve in a 2-inch line? So that's just another safety. The connection is screwed because it's a small valve. Here, the next thing to do for simplicity is if I told it already it was proportional over here. If I select my valve, it puts that information in for me, which I could have put in manual if I wanted to. MFT configurable, auxiliary switches I'll go back to. Safety functions, we're going to select spring return. It's NEMA 2, and it has a close off of 200 PSI. I'm going to scroll down, and I hope everybody sees this okay. Now notice I selected a 3/4 inch B220 HT731, 7.31 CV. Perfect, perfect. And it's given me 2 different actuators, one with a switch, you see the dash S, and one without. If I went here and said no auxiliary switches, how easy. It just selected one actuator for me. It will select multiple actuators that when you're doing the valve schedule, you generally know which ones you want to pick. And that might take some time, that might take a little training or redundancy just doing it or looking in the catalog, but it's pretty easy. So now I selected a valve and I'm going to add it to my schedule. I put it into the schedule, and this here is going to let me decide what I want to see. Do I want to show it as a price and notes? You could change the multiplier, or you leave it at 1 to see the list price. You know, we don't. List price is just a published price. There's always multipliers. But you could also select custom attributes and show whatever you would like to show. Very great tool. This is what I do for the engineering groups, because all I'm showing them is how I selected the valve, what my criteria were. Okay? So I didn't want to do that. And I want to go back here. Now, data sheet, if you selected that, which just, I can't believe this feature, because we selected the entire valve. I just pulled the data sheet that easy. And there it is. So if you have to do submittals, you have it. It's as easy as that. And close out of that. The data sheet, the actuator will be on the bottom of it with all the specs, usually for the engineering group. And where did my presentation go? Okay. So that's how simple SelectPro is to use. And it has all those other functionality. It also has energy calculators on it. It's really a worthwhile tool to take a look at. If you have an issue or you need more information, you can go online. You can go into our catalog and find your district sales manager. That's throughout the world. So it don't matter where you are. We will have somebody that can assist you. You can find me. If you want to discuss STEAM applications. And with that, I think we are ready for questions.
Yes, we are. Thank you so much, Bob. We do have a couple of questions that came through, so thank you so much for all of you participating in today's webinar. We are a little over for time, but I see that most of you are still here, so I'm going to go ahead and ask some of those questions. Just a friendly reminder, to ask a question, you can open up the question box, type in your question, I'll read them aloud, and Bob will answer them as best as possible. We do have a handout today available for download immediately. It is the 2019 Product Guide and Price List. And as always, our webinars are recorded and will be posted to our YouTube page at a later date. If we are not able to get to everyone's questions today, fear not, we'll reach out to you and get those questions answered. All right, Bob, are you ready?
I'm ready.
All right, so first question, can Belimo valves be used for steam humidifiers?
Yes. If the steam, it's up to the manufacturer of the humidifier. Some humidifiers, many humidifiers use our product on them, and the needle valve will be built right into the actual humidifier system. Now, a lot of Belimo valves are used for isolation, but if it's a very specific needle valve that the manufacturer, like an Armstrong or someone, installed on it, then you have to go to the manufacturer to be sure. So it's not a total yes. That's something you have to be sure it's the right application.
Okay. Bob, this is referring to a previous slide. What does 1/3 to 2/3 mean?
Okay, 1/3, 2/3. It's not 1/3 to 2. It's a 1/3, 2/3 system. If I had a heat exchanger that was calculated at 1,000 pounds per hour, and I know my loads are going to be dramatically different, instead of using one valve, I would use two valves. I would size one valve with 333 gallons in the next pounds per hour, and the next one for 667. So instead of having one 4-inch valve, say, I would have a 2-inch valve and a 3-inch valve. Then I could modulate at low loads. I would open the small valve first. And as the loads get high, when everybody's taking the shower or you're warming up the building, the big valve starts opening. And this takes away, first of all, it gives us much better control at various loads, demands, and it takes away from a lot of the wear on the valve. One of the worst things we can do to a steam valve is oversize it. If a steam valve is oversized, it's going to work off its seat. It's just going to crack open a little bit, and that steam's running through there at over 100 miles an hour, and it's going to damage it. So that's where we use 1/3, 2/3, generally on steam to water heat exchangers.
Okay. Next question. What happens to the HTCCV if we exceed the max DP?
Okay, that's virtually, well, the valve would wear, but that's virtually impossible because the max pressure is 15 psi and the max DP is 15 psi. So it's rated for its full inlet pressure. But any valve, let's talk any valve to answer the question, you're going to prematurely wear out the valve.
Okay. We have time for one last question. And if you do have any questions after the webinar, you can feel free to contact myself and I'll get them over to Bob so he can answer them. Okay, considering the same inlet pressure and capacity, why do you need higher CVs for on-off applications than modulating?
The modulating application, yeah, right, on-off, you just want to make sure you're not causing any resistance when an on-off. You want the valve, the steam to flow as free as possible. Whereas modulating, you have to begin to choke the flow in order to be able to control the volume of flow. And basically that's it. There's no need for that smaller orifice when you're not modulating, and you don't want to cause more of a resistance than needed. It's as simple as that. You could do that. You could calculate to your exact pounds per hour on off, but there's literally no reason to do it. The trap is controlling the flow. The trap is, this valve is allowing the water to go into the coil or heat exchanger. The trap is holding it back till it condenses into water to a specific temperature or flow, a specific volume of water, and then firing and allowing the water, the steam to flow again, to be turned back into water. So there's no reason to cause any other resistance. Whenever the steam is hitting a wall or anything, it's turning into water. You're taking apart the characteristics of saturated steam. So on-off, there's just no absolute. But if you wanted to say, I need exactly 257 pounds, calculate your CV and your inlet pressure, yes, you could do that. There's no reason to.
All right. Well, thank you everyone for participating in today's webinar. Thank you so much, Bob, for that excellent presentation. Our next webinar will take place on March 6th at 1 p.m. and it's going to be on our brand new Belimo hydronic tool. Once again, thank you everyone and have a great day.